let's discuss what this means for us. The internal assessment is an important element of this course. So I'll be kind of guiding you through. I know it's a lot to look at right in front of you right now, so I'm going to kind of break this down and describe the most important elements I think you need to think about. Okay, good. All right. What do you brought over from earlier?
Yes, sir.
Okay, good. I was like, did I accidentally hand that? So this is, or you might call this a practice internal assessment because none of you are in the year where you're testing at the standard level or the higher level. But this will be entered into our grade book this year here in a couple different ways. The most important way that you might be interested in is that it's a 40-point test grade in the fourth quarter. So it's gonna take a little while to do this project. I'll grade it and finally it'll go in that. There'll be little grades along the way that go into the third quarter grade categories. Some peer editing things, some reflections, some drafts, and things like that happen along the way. But the big grade will be a 40-point test grade in the fourth quarter. Yeah. No, I don't know. But we haven't wrote that one. You mean the festival? The festival. Just wanted to be clear. That being said, even though it might sound like this practice internal assessment, for some of you, you may actually make this the portfolio, the piece of the portfolio that you submit to IB. So there will be some people who, especially if you tested the standard level, you could just submit this as your portfolio too. We're going to keep them on file when we're all done with this. All of you will be submitting two, so I can hand one back to you, and we'll retain one, so that if the time comes that you tested the standard level, you don't have to make that decision yet. We can just submit that as part of your portfolio. And it also may be for you the kind of thing you want to make, use as a jumping off point for your higher level internal assessment when that time comes. So, but it is a good time to just mention how the internal assessment works for IB. So in the year that you test, there are two components of your grade. There's 80% the external assessment, or the test you sit for, and that's half and half. If you're doing SL, it's half and half paper 1 and paper 2. There's a paper 3 also. It's smushed into that 80% if you're doing higher level. But 20% of either your SL grade or your HL grade is made up of not a test, but this large paper that you write on a topic of your own choosing. And it's called the math exploration paper, and that's what you're going to be writing this semester, along with other things we'll be doing. It's an individual exploration, although, as I'll say on some other slides more clearly, I do encourage you to bounce ideas off of me and your other students. We'll spend 5 days in class, the first 3 of which will happen right now, here, today, tomorrow, and on Wednesday. And then there'll be 2 other days where we have kind of some check-in days where we peer grade and peer review, things like that. But a lot of the work will be done outside of class on this. I think it's important to highlight the purpose beyond, of course, but one purpose is, of course, because it's a requirement of the IB program. But also there's some mathematically lofty purposes for us to do this too. I'm just following. By the way, there are no surprises here. This should be all printed exactly word for word on the thing you have in front of you. So I just want to give you some highlights here. I won't read them out for you. One thing that I want to highlight too is that hopefully this is your chance to experience the beauty and the power of mathematics for yourself. So hopefully that's a lofty goal, but I hope that happens in your life as you do this. The other thing I should say is that I think that in almost an artificial sense, the math curriculum often comes to you all throughout school so far, right? It comes to you in very nicely pre-packaged ways, doesn't it? We give you problems which we know have solutions, and furthermore, problems that we know have solutions that you'll be able to find within a 45-minute period. Most problems we give you are well-defined and wrap up within 10 minutes of your life, right? But of course, in the real world of mathematical research, that's just not the case at all, is it, right? You might work on a problem for 10 years with no solution, right? Or with no resolution, and you're just banging your head against the wall, hoping that eventually it breaks. For example, I don't know if any of you had Miss Pestalante for Algebra 2 last year or anything, but her husband works on the Riemann hypothesis. That's just all he does. It's unproven, and not right this second, but you can come by sometime. And that's all he does. And it could be that in the end he never finds a solution. But that's all he does. It's an incredible amount of tenacity. So I just want to underscore this one here, right here, down this whatever bullet point, second to last bullet point. It says patience and persistence. I'm not sure that that's a mathematical attribute we cultivate enough. But that's what I'd love for you to do. I'd like you to be, in this project, engaged in a large mathematical task that it requires you to like break it down into smaller problems and to attack it with persistence, hoping that eventually that it will break under your massive intellect. Is there another important thing there? I think I've kind of highlighted yeah, and hopefully down like this last one says, this will be something that builds confidence too. I think you get the point though that we often give you kind of very well defined tidy problems in mathematics. One of the big I think one of the big pieces of mathematical research for us, for mathematical researchers, is even in formulating questions. So that's something that we're going to practice doing too. I don't know, you have a lot of practice like answering well-defined questions, but you probably haven't had a lot of practice formulating questions in mathematics. So that's something that I hope that will be a thing that happens here too, is that you'll get some practice doing that. Yeah.
When it said significance,
yeah, go ahead.
When it said significance on the previous page,
Yeah.
what does that exactly mean? Because there are multiple different definitions of significance, which can also vary between different fields.
Can you show me where?
Below, develop the qualities of patience and persistence to reflect the significance of your work. Which definition of significance do you mean?
I mean, I would hope that you find whatever you do to be like worthwhile and not worthless.
Oh, so you mean of importance instead of something that is not by chance, such as how it's used in scientific and mathematical fields.
Sure.
Sorry,
this is an independent project. So the independent project is, like I said earlier, it is meant to be your own work, but I do encourage you, and I'll even create space in this classroom for us to talk with one another about your work. And I'd love for you to, like, you know, if you get stuck, to ask someone that a friend or something like that, or me, or if you want to consult like some professor or something like that, that'd be fine too. Whatever. Along the way, I want you to be encouraged to seek guidance where you need. In the end, of course, it's your project though, and you're writing your idea. I hope that will be true. I want to take this moment too to just make sure that you understand. I think that your English teachers talk to you about plagiarism and things like that, but I do want to make sure that that's like a focus we have. If there's any question in your mind about whether something you think you're working with has been cited accurately, I want you to cite in line anything you might use. So, I mean, even one sentence stolen verbatim from another source without attribution is plagiarism, right? So, I mean, we have given people zeros in the past for the project due to that. I just don't want that to be you. So I want to have that conversation up front. So just make sure that it's a very uncomfortable conversation to have with you later. But if you do it now, like as you write, in the process of writing, you're like, hey, Mr. Cheese, I'm not sure, does this count as, like, am I showing academic integrity in the way I've, like, treated this source material? That'd be a great thing to talk about. Like, I don't know is this full or do I need quotes here? Whatever. We can talk about it ahead of time if you like, but I just don't want that to happen. So, like I said, this is like a big part of what you're going to be doing, and we'll actually spend a whole day or two here talking about how to choose a good topic, because I feel like that's like such a huge, important part of this process. Choosing a good question, I think, like I said, is important, and it's hard, I think, to ask good questions in mathematics sometimes. A good question is sometimes hard to find, but you know it when you found one, right? It's one that challenges you, but isn't too challenging, right? It's like right at your level. You want something that's not too easy for you, but not something that also is something you can tackle. So hopefully it's a question that will, for you, create mathematical tasks that are like relevant to your current level of mathematical expertise, right? So that would be things you're learning right now, hopefully, in this course. Hopefully it doesn't just involve like math you learned in elementary school or something like that. And I also think it's a good, coming up with a good mathematical question is, like I said, maybe a little bit harder than you think. Let me say this. A lot of times when we give you a math problem in math class, we give you a problem that, like I said, is very tidy. We either give you these we never give you too little information to solve the problem. And yet that's often how it comes to you in the real world. If you're like solving a math problem, you might be like, oh, there's an important piece of data that we just failed to collect. Like, we need to go get that, right? Wouldn't that be interesting if I gave you some math problems like that in class? Like, where you're like, wait, there's missing information. But we often, so that's often what happens in the real world, though. You need to go seek more information in order to even tackle the problem. Or the opposite might be true, right? An overdetermined problem would be one where you have more information than was needed, and you're like, well, how does this work into the problem? This doesn't seem like we always give you exactly the right amount of information, it seems, in a math problem. But in the real world, that's the kind of thing you encounter. Sometimes you're flooded with information, like way too much more than you ever needed, and sometimes you don't have enough. And in both tasks, you might need to define the problem before you can ever even get into it. I hope you become people who ask good mathematical questions as a part of this process. Just an anecdote that I like, because I think some of you are like, do mathematical research. Like, what does that even mean to do mathematical research? I understand what research looks like in other fields. You maybe go ask people questions, or maybe you're in a lab and you're using your lab skills or something. That's what research looks like. But what does it look like for a mathematician to be hard at work? This is the anecdote I like to share. I don't remember where this comes from, but you're visiting on a college visit, say, the math department at some prestigious university. You're walking down a hall. You look in one math professor's window, and he is busily working on his latest manuscript. He's preparing his next lecture. He's at the computer poring over some data. And he's clearly a busy guy. And you walk to the next window, and you see another mathematician professor who's got his feet up on the desk. He's just staring out the window. He's lost in thought. Well, he is perhaps the mathematician who is harder at work, right? Maybe and that's what I kind of want to communicate to you too. It's not really number crunching. That's not really. That might be certainly part of mathematical research, but a lot of times it's the creative act that's the mathematical research, right? It's the formulating of questions. It's the time you spend at the whiteboard. It's the time you spend on sheets of paper scribbling and erasing and hitting dead ends, and that's where the mathematical research lies, doesn't it? A lot of times is in that creative pursuit. And I hope that's what you see as you do this, that this will be for you a creative pursuit, not just a computational one or something. Good questions would be ones that put you in these directions, right? So, I've developed a formula that applies to natural numbers. Well, can you extend it to make sense for, all real numbers? What about non-real numbers? Or what? You come up with some result in the coordinate plane, two-dimensional geometry or something like that. Can you extend it to the third dimension, or possibly even the fourth or fifth dimension or something like that? Is that something you can extend? Maybe you come up with some, you've investigated some kind of pattern. Can you make it even more general, right? This is the idea here. Modeling is a great one too. I've used a source of data that I found on the internet and I've done some stuff with it. Okay, cool. And then maybe I hope that drives you to collect your own data also and compare and see, right? Go deeper, go extend, model, generalize. I think that's a great, those are great directions to go with a problem to make it deeper and more interesting. So we'll say some more about choosing a topic and asking good mathematical questions as we go forward. But let me just talk to you for a moment about the nuts and bolts a little bit. And again, are you following along here? Are you finding these things? Hopefully you don't have to write anything down necessarily. You can make some notes on the side, but I have it all here for you too. I put this page, kind of rough page estimate up here because people are always kind of curious. I just say that because that's often what we get is results that are between 6 and 12 pages in that neighborhood. I just kind of made that up, but I think that if you hand in something that's 2 pages long, it's probably insufficient. I can't say. It might be that you're a master at being concise. I don't know. But whatever does the trick, right? But your paper might be longer if you have some large diagrams or something. That's not. But how is it? How do we judge the length of a math paper when there might be a section where you're showing some working math, or there might be a section where you have a chart or something, or you have a table on a page, or whatever. So I don't want to come out and say what the length requirement would be necessarily. I just normally get things that are in that neighborhood. So yours will probably, I hope, be in that neighborhood too. Hopefully it's not 20 pages stapled and yeah. So that's usually what we expect. What else was I going to say about that? Oh yeah, as long as you give a rich and thorough treatment of your question, you answer the thing question you set out to answer. I think that will be good. We gave you some good practice word processing math at the end of this last semester as you did your review problems. So hopefully that was a good experience. And I'd like, of course, this paper in the end to be nicely produced, beautifully produced. And if you need any help with producing mathematics in your papers, equations, or diagrams, or tables, graphs, I can point you to resources. There's not a hard line on this, but you can be a good judge of this, maybe. What should appear in the appendix? What should appear in the body of the text? You can make that decision. But you know, maybe, I don't know what the rule of thumb would be, but maybe if it's more than a page long, you put it in the appendix or something like that. If you have a table of, but if you have a table of data that you think would be helpful to the reader, then maybe just include it right where they're reading. Don't, and certainly if you have like a picture of something that you need to have that helps the reader, don't be like, see appendix A for the picture of, to see this graph or something. Just put it in line. I have a handout that spells out some more details about how to communicate mathematically, so I'll hand that out in a minute here. Use any style guide you like. But do please obey some systematic style guide, especially as it relates to citation, right? So whatever you're doing in your English classes is probably okay. Whatever you do, make sure that you have inline citations though too, like if you pulled a quote from someone or you have some data from somewhere, just like say this is from source one or this is wherever it comes from. So I've heavily produced this myself, but it also is taken, the first page especially, is taken from another resource from a college professor. So some of these apply more or less to us, but I'll make a few highlights from here. We won't read it verbatim right now. I will highlight a few. So yeah, let me make a few comments about this. Let's see. Like it says, I've underscored at the top down here, on the bottom over here, and then the top up here. Your ultimate goal is to communicate above all else, right? So these tips are just to help you do that. So number 2 is again there. This is like writing. So my expectation would be for you to like not just like have a bunch of math that's spewed out and given to me, but that this is actually writing, right? There's going to be an intro, an inclusion. If it helps you think because your paper needs some organization to have like section title or something like that, do it. Okay, whatever helps the reader get into your paper with clarity is something you should do. So anyway, so this gives some hints on that. Mathematics in particular avoids, like it says on number 3, flowery language or imprecise language. Right? There's no need for us to like know how you feel about anything really, even though. Yeah, I think I'll get that vibe from you, right? Like just because your excitement about the material will just speak for itself, I'm sure. So the number 4 I think is important. Know your audience. That is, for us, that would be a mathematical peer. That's your other pre-calculus students here at Richard Montgomery should be able to read this with understanding. So don't dumb it down, but don't like make it so difficult or dense and expect people to follow you that are in college or something like that. Don't write it to me, write it to your peers. Right? So with that in mind too, I'm going to skip over a couple of these. If you look at, for example, number 8, how much detail should you give on a procedure, right? Well, if you're, like this example shows, if you have a quadratic and you want to tell me what the roots of that quadratic are, just tell us. We're all adults, right? Like we can, well, are we? Actually, I don't know about that. But whatever, we all know how to solve a quadratic equation, so please do not go through the details of solving that, right? Just be like, here's a quadratic, its roots are this, right? We can all trust you on that, and we all know how to do that, to fill in the gaps if we needed to. But if you have a new procedure, a new algorithm, or a new thing that none of us has ever done, well then please solve every detail. I hope that makes sense, right? Again, it goes to the point we talked about this a minute ago. Number 9, you can somewhat ignore in this context. That's not super important for the paper we're working on. Number 10 gives you some fancy words if you want to sound smart. Do you like those words? Did you read them? I like that. It follows that. What else is on there? Moreover, look how, see see how smart you'll sound if you use those words. Okay. Good. Number 13 is worth mentioning. Be precise with your notation, your language. Yeah. I don't know. There's sort of dimensions that maybe you've never heard of. Like, did you know, for example, that we always italicize our variables in mathematics when we write our variables, or that we don't allow sin x to start a sentence, number 12, or like a function. We usually don't try to. We always try to start with like an English word. And then I won't say too much about the back, but the back sheet just gives you some pointers on how to enter equations and in Microsoft Word and graphs and things like that. And if you don't, I highly recommend Microsoft Word because I think it does a very nice job of rendering these. But if you're using some other equation, some other word processor, every word processor has some kind of equation editor built into it. Even if Google Doc has one, OpenOffice has one. Like, so whatever you're using out there, it will have an equation editor. You can be sure of that. So there shouldn't be any need to not do that. Good, but again, communication is key. Make sure you're writing clearly and communicating clearly. Everyone understands what you're saying. I think it's time to take a look at some of the assessment criteria, and these are written in your packet there with more detail. So I'll just throw these five up there, and I'll say a few things about them. I might commend to you the paragraph above at the start of each criterion. So like for A, criterion A, it says, we're back in the previous packet, by the way, are you following along? So it gives it says criterion A, communication, and it has a little paragraph, and then it has like kind of a rubric box that kind of describes the different levels of achievement for that task, right? So communication is just what we've been talking about. It's about multiple representations. It's about section headings. It's about intro, conclusion. Have you written well? Does your point, does your exploration convey in a meaningful way to someone? Is it actually readable? Those are all things that deal with communication. Mathematical presentation has to do with the form of your mathematics, right? Like we're talking about like notation and language. Have you used precise definitions? Have you reasoned clearly? Have you, that kind of stuff. Both of those are kind of A and B, are wrapped up in the things we've just been speaking about most recently, right? In these documents about communication. Personal engagement, we should say something about. The way I see personal engagement most is not by you saying, like, I was really engaged, like in your paper or something like that. I want to see your engagement. I want to see how much you enjoy what you're doing by your clear persistence in the way you pursued the problem, right? And that'll be clear from the task you set forth for yourself. You say, you get to the point where you've answered the question, you're like, I answered my question, but you know what? I wanted to go further. I generalized it in this direction, which I wasn't even planning to, and I'm like, and it's the kind of thing when I read it, I'm like, oh, that is awesome. Like, I'm so impressed that you would even think to try to go further with that. Or you get kind of through this, and then you say, now I'd really like to take a look at my own data, or maybe I want to look at a second data set, or whatever it might be. That extension, like we were talking about earlier, that desire to model or to generalize or to extend, those are all things that show me that you're engaged, right? That you're like, you really like this. You didn't just like settle for the bare minimum. Reflection, again, I think it's tempting to be like, oh, well, I should be reflective in my essay. So I'll have like a section at the end near the conclusion that says like reflection. Well, there is that, and that's certainly one way to do things, but what I would recommend is that you have reflection everywhere. It should be like something that saturates your paper. At every turn, every time you make a statement, you're also considering the scope and the limitations of that statement, right? And you're considering all the way along, especially if you're doing like a real world thing, you're considering at every turn error sources and error analysis, and you're thinking about different ways of doing things, different representations. At every turn, you're showing me that like you're not just doing things thoughtlessly, but you're doing things like really in a reflective way as a mathematician. And then E is obviously, the one that has most to do with the actual mathematics. Is your mathematics at the level of the course, and is it correct? Is it actually right? I would like it to be right too, after all is said and done. Keep in mind, your mathematics could be like wrong, and you can still score really well on your paper, I guess. I mean, this is not necessarily like other math assessments we've done, right? We're awarding a lot of points for just clearly communicating your thoughts and ideas, pursuing this with tenacity. All right, so we have a calendar here on the next page, I think somewhere there, right? As far as where we're going with this. These first 3 days, we'll be doing these things. I'm actually giving you a little time here to do this feasibility study. I'm actually calling it a topic proposal or / feasibility study. I really would like, when I say topic proposal, I really do want you to consider it almost more like a feasibility study too, because what I'd like you to do is not just be like, well, I think I'm going to do something about like eclipses or something, or I think I'm going to do something about like prime numbers. No, I'd really like you to like formulate very clearly your question. And in order to do that, to know that it's a good question of the kind that I talked about earlier that like is going to be the perfect right challenge for you, I think what you really need to do is like actually start doing the problem, like actually start working on it a little bit. If you think you're going to get, because how do you know you're going to be able to collect that certain data? Maybe like when the time comes for you to collect it, it's like not there. So actually go out and look for it, like, or start, whatever the first step is, wade in just a little bit into the water of your problem, just to know that it actually will work. So by this topic proposal, I don't just want you to kind of give me vague generalities. I'd like you to actually write, it doesn't need to be more than like a page or so, just typed, right? So when this due date comes, that's what we're looking for. Just 1 page, or I mean, you can do it in 2 paragraphs or 3, that's fine too. Whatever it takes to convince me that your topic is tenable, right? That like it's actually going to result in like a really interesting and challenging question for you, and it's going to produce a good exploration. Whatever it takes to convince me of that. But I don't expect it to be, I expect it to be about a page or something, right? The feasibility study. But I don't want it to just be called a topic proposal. I really do want you to like test and see whether you think it's actually going to work. Is this going to work? You don't have to go too crazy, but at least try and figure out whether it's something that will actually work. The first draft will be due on March 6th. Hopefully you're getting these dates on your calendar. And then this is, I think, the most important deadline here, the kind of the big last one here. It's March 13th is when the final draft is due. And the only edits, I really want that to be like completely done, polished, perfectly typed, beautiful, bibliography there, intro, conclusion, everything is just absolutely perfect. Diagrams, stapled, crisp, nice printout. Perfect, right? Now, I will say, we're gonna do some peer editing that day, but the only kinds of edits I hope your peers will make on this day are like, you spelled this wrong, or like, you should really consider moving this paragraph here. Like smaller changes, like hopefully they're not like, on this day, if you have like still like a to-do item, or like, I still need to flesh this out, or I haven't solved this part of the problem, that would probably be forgivable. But here, like that would be perhaps unforgivable, right? If you have like to-do items still, right? So that really needs to be done completely by March 13th, like ready to hand it. Like it says on there, I kind of flesh each of those out more on your paper in front of you, right? So you can see what my expectations are. So in the coming days, I'd like you to start thinking about your topic. We'll spend a lot of time like practicing even tomorrow, and how to ask good questions, and we'll actually practice together asking. I'm going to give you some topics, for example, and we're just going to like think and brainstorm. We're going to try and come up. I'll give each group, we'll be in groups, and I'm going to give you each group a topic to think about, and you're going to just come up with as many questions as you can of a mathematical nature about that one topic or something like that. So that's the brainstorming mode I want you to get into, and so we'll practice that some more in the coming days. I think this is a decent place to stop. Both, all 3 nights here, tonight, tomorrow night, and Wednesday night, your homework will be similar, and that will be to grade sample IA. Okay, so tonight I have for you an IA and a score sheet. You're going to score it at 20 points on the criteria that I just outlined with you. So I think that's a great way to get into this as far as like what do these things look like actually. Okay. Sorry to talk to you so much here. You guys have all been very attentive. Yeah. Oh, shoot. Yeah. I meant to be passing around a blue marker. Sorry, I apologize. Can we still do it? Can you write with a blue marker on your stick, your name? Make sure it gets around. And on the way out today, you'll just put your stick and your card back up there when you're done. Did I give everyone, did everyone get the Minesweeper paper? All right, here comes the score sheet now too, right? And so out of 20 points, we'll score it. Give some details about why you justify each of your grades. Don't just give me some numbers. Really do read it. This is all your stuff to mark up. So feel free to like write all over the essay that you got the paper. Okay, did everyone get what they need here?